Hello and welcome to another informational video. The topic I'll be discussing today will be on the OSI model, or the Open Systems Interconnection model, and what layers in particular to the OSI model we're able to configure encryption on, as well as the type of encryption. So the OSI model is broken up into 7 layers. This is for the purpose of breaking up the data communication processes in our network and separating the functions of hardware and software components into different layers. Each layer performs a different group of tasks required for the network communication. So this is the process of encapsulating and decapsulating data. Now, the OSI model isn't necessarily what you would consider like an across-the-board standard, but it serves as more of a functional guide. The more that you can understand about the OSI model, the better idea you'll have as far as designing network protocols, software, and appliances, but also troubleshooting networks. So you can think of the OSI model as a layered table of sorts, and where you begin on the table is really kind of dependent on whether you're transmitting or receiving the data. Typically, you'll start at the bottom and it begins with layer 1 up to 7, or vice versa. But starting from layer 1, the communication goes physical, data link, network, transport, session, presentation, and application. A good way to help you remember the layers is to set them up with an acronym or a mnemonic phrase like PDNTSPA, where the mnemonic phrase I learned for this was, "Please do not throw sausage pizza away." Now we'll go ahead and go through the examples of each layer, but before that, I'll just state that when you're looking at layers 1 through 3, these are considered responsibility of the network layers, while the layers 4 through 5 and so on are considered the responsibility of the host layers. So the physical layer, defined as layer 1, is the layer responsible for the transmission and receipt of the signals that represent bits of data. You can classify the transmission media as either cabled or wireless. And this layer is going to specify the physical topology of your network, the physical interfaces, and the type of signaling. Some of the devices you're going to see operating at the physical layer are things like coax and fiber cables, transceivers, repeaters, hubs, and modems. Moving on to the data link layer, defined as layer 2. This layer is responsible for transferring data between nodes on the same logical segment. So a segment is where all nodes can send traffic to one another using hardware addresses, regardless of whether they actually share the access to the same media. Each host is connected to a central node, such as a switch or a wireless access point, which is or will provide a forwarding function, basically getting the communication from one node and sending it to another. The addresses of the interfaces within the same layer 2 segment are described as local or hardware addresses. The data link layer also performs encapsulation, which is where it organizes the stream of bits from the physical layer into structured units, which you may have heard of referred to as frames. So this layer adds control information, which includes source and destination hardware addresses, plus a basic error check to test if the frame was received intact. Devices you'll see operating at the data link layer are network adapters, or NICs, which is a network interface card, bridges, switches, and access points, which could be either wired or wireless. Next, we have the network layer, or layer 3. This layer is responsible for moving data around a network of networks, otherwise known as an internetwork. So while the data link layer is capable of forwarding data by using hardware addresses, the network layer moves information by using the logical network and host IDs. So the main devices you're going to have working at layer 3 is your router, but you'll also have a firewall that operates at layer 3, filtering traffic to enforce your ACL, your access control list. And all that is a list of the addresses and types of traffic that are either permitted or blocked. Moving on to layer 4, we have our transport layer. So while the first 3 layers of the OSI model are primarily concerned with moving frames between nodes and networks, at the transport layer, it's the content of the packets that becomes the focus. So this layer tracks the communication between applications on source and destination hosts. The transport layer identifies each type of network application by assigning it a port number, such as, say, like port 80 for an HTTP web application, or port 25 for data sent to an email server. At the transport layer, data is packaged as a series of layer 4 PDUs, or protocol data units, which you can think of as basically like a chunk of data. And these are referred to as segments. So as stated before, each segment is tagged with the application's port number. So the segment is then passed to the network layer for delivery and so on and so forth down the following layers to the destination host. Devices you'll see working at the transport layer include multi-layer switches, usually working as load balancers, and many types of security appliances like more advanced firewalls and intrusion detection systems, or IDSs. Moving on to the upper layers of the OSI model, these layers collect various functions that provide useful interfaces between software applications and the transport layer. So starting with layer 5, which is the session layer, most application protocols require the exchange of multiple messages between the client and server. This exchange of messages is called a session or a dialogue. So layer 5 represents functions that administer the process of establishing a dialogue, managing data transfer, and then ending the session. So some examples of this are ASP, like AppleTalk Session Protocol, ADSP, which is the AppleTalk Data Stream Protocol, NetBIOS, and PAP, which is the Password Authentication Protocol. Moving along to layer 6, or the presentation layer. This layer transforms data between the format required for the network and the format required for the application. So for example, it's used for character set conversions, such as between American Standard Code for Information Exchange, or ASCII, and Unicode. Example of this are like MIME, which is your multi-purpose internet mail extensions, or encryption and decryption services. The final layer is the application layer, or layer 7. And this is at the top of the OSI stack. An application layer protocol doesn't encapsulate any protocols or provide services to any protocol. Application layer protocols provide an interface for software programs on network hosts that have established a communication channel through the lower level protocols to exchange data. More widely, upper layer protocols provide most of the services that make a network useful, rather than just functional, including web browsing, email and communications, directory lookup, remote printing, and database services. Examples of these include HTTP, which is your hypertext transfer protocol, HTTPS, which is the secure version of the hypertext transfer protocol, SMTP or TP, which is your simple mail transfer protocol, DNS, which is your domain name server, and FTP, which is your file transfer protocol. Now, real quickly before we move on to the layers that we are able to configure encryption on, as well as the type of encryption, I want to just do a quick summary on the OSI layers, listing the different PDUs and devices at each layer. So just as a quick recap, layer 1, your physical layer, we have transceivers, cables, media converters, hubs. Between layer 1 and 2, we have network adapters and access points at play. Layer 2 is your data link, which you have your frames, MAC addresses, EUIs at work with your bridges and switches. Layer 3 for your network, you have your datagrams, IP addresses working with your basic firewalls and routers. Layer 4, which is your transport layer, that's where you have your segments at work. Layer 5, layer 6, layer 7, the session, presentation, and application. These can all kind of be merged together somewhat, where you have multiple layers at play, providing application protocols. So your web, email, file transfer, stateful, application layer, security appliances, multi-layer switches. So now we'll discuss the encryption configurations for the different OSI layers. Starting at physical layer 1, we actually have optical encryption, which encrypts raw data bitstream as it travels over the physical medium, such as like fiber optic cables. This is used in high capacity, long distance networks to provide or prevent physical tapping. Example of this are optical transport networks, or OTNs, securing high speed optical communications over long distances. At the data link layer 2, we have MACsec, which secures communications between directly connected network nodes at the frame level. This is most often used for encrypting traffic over a local area network, or LAN. Examples here are like point-to-point links or Ethernet links. At layer 3, we have IPsec or IPsec, which encrypts data at the packet level, protecting all traffic that travels across an IP network. It is commonly used to create virtual private networks, or VPNs, which is an encrypted tunnel to protect data as it crosses an unsecured public network. At the transport layer 4, we have SSL or TLS encryption, which manages end-to-end encryption between two endpoints. While the handshake is initiated at the presentation layer, the bulk of the encrypted data is managed and transferred here, ensuring reliable and secure transfer of data segments. Examples of this are encrypted web browsing, secure email, as well as some other services. At the presentation layer 6, we have some overlapping encryption with the SSL and TLS. Here we handle encryption, decryption, and data formatting for the application layer. In modern implementations, these functions are often integrated with the application and transport layers. Examples of these being HTTPS encryption, which secures web traffic, using TLS SSL, which is responsible for adding encryption to and removing it from the HTTP data. The last and final layer of encryption here goes to application layer 7, which has application-specific encryption, providing encryption at the highest level, directly within an application. This offers protection from the point of creation to the point of use. Some examples of this being S/MIME and PGP, which is secure email communication, secure file transfer, which encrypts files before sending them with an app like FTP, and secure messaging with lots of different messaging apps used for end-to-end encryption. Now, as I had mentioned in my previous videos, specifically on encryption, these protocols are essentially divided into two categories on whether we consider them protocols for secure communication or protocols for authentication. But with all that being said, that does bring us to the end of this video, and hopefully you have a better understanding of the OSI model and some of the encryption techniques associated with the stack layers. I appreciate your time, and as always, I advise you to continue learning. Thank you for your time.